Okay, welcome to the Unit 4 CSA study guide. The date of recording March 2021. We begin with number 1. What is the solution to this system of linear equations? So we have two diagonal lines crossing at a single location. A location is a point on the coordinate plane from the origin at 0, 0, and it consists of an x, comma, and a y. That's an ordered pair. So you describe how far along the x-axis you travel and then how far down the y-axis. So this point is located 3 to the right of the origin and 1 down, which would be 3, comma, -1, since you went down, which would correspond to B. Problem 2. Match the correct graph with the given system of linear equations. So we're given two linear equations, and we're asked to find and match where they go. Now, before you begin, you might start by thinking, I need to think about where these might cross. And you can do that with sketching it on a separate piece of paper to begin with. So there are several things you know about this line. We use y equals mx plus b for graphing, where we know m is the slope and b is the y-intercept. Where they graph starts. So this graph starts at 0, 4, and this graph starts at 0, -3. The slope on this line is -1/3, which is down and right. And think about how steep it is. Is this steep or flat? It's negative slope. So it's going down the page as you go left to right, and it's flat, relatively flat. Whereas this slope equals 2/1, that's there, which is up and right, and this line is going to be steep. And it's traveling in the positive direction. So if you think about that on a graph, this line starts at 0, 1, 2, 3, 4, goes down and right 3, and down and right 3, which is a relatively flat line going in the negative direction. And this doesn't have to be perfect because it's a sketch. And I go to -3, and it's steep. So I already know it has to intersect here in quadrant 1 because this line's going to be steep, rising 2 and running 1, rising 2. It intersects actually right there. So if I see any lines intersecting outside of quadrant 1, let's say in quadrant 4 or quadrant 2 or quadrant 3, if I see intersections in any other quadrant, I know those are for sure wrong. So let me find the lines that are intersecting in quadrant 1. This is not intersecting in quadrant 1, so A is wrong. Okay, we'll zoom out just a little bit and take a look at B and C. Now, both B and C are intersecting in quadrant 2. That's very good. Quadrant 2 and quadrant 2. Notice the slope of this line is positive, though. And this slope is positive. Whereas you have a positive slope here and a negative slope. So there's another way that you can just quickly find your answer. Ultimately, you want to find one that is moving, rise 2, has a slope of 2. This line rises 2 and runs 1, rise 2, runs 1, rise 2, runs 1. So That's the same as this line. The only difference is this line is traveling rise 1, run 4. So this line is y equals 1/4 x plus 4, whereas this line is y equals negative 1/3 x plus 4. So it has to be graph C. Problem number 3. What are the coordinates of the intersection for the following pair of linear system? Okay, well, again, we have a couple ways that we can do this. We have these two lines here. We can do the same trick that we did before, where we thought, oh, well, which quadrant will these be in? Remember, quadrant 1, the coordinates have to be positive and positive. Quadrant 2 has to be negative, positive. For your x, I'm talking about your x and your y. The signs of your x and y both have to be positive in this quadrant. Negative x, positive y here. Negative, negative here because you're going left and down for quadrant 3. And quadrant 4 would be positive, negative. So if we look at these coordinates here, they're both positive. That's in quadrant 1. Negative, negative is quadrant 3. Positive, negative is quadrant 4. And negative, positive, they're all in different quadrants. This line starts at 3 and has a negative slope, so it's going in this direction. This one starts at 1, 2, 3, 4, 5, and it's got a positive slope, so it's going somehow this way, and this one's going this way. So they either have to be in quadrant 1 or quadrant 4 because the lines have to intersect over here somewhere. So let's get rid of the bad answers. Only possible in quadrant 1 and 4, so B is out and D is out. Now I'm going to solve it by graphing. Let's see. This is 0, 3, and it goes, you start at 0, 3, and the slope is down 3, right 2. 1, 2, 3, right 2. Down 3, right 2. First line. The second line is 0, negative 5. We have that here. And rises 1 and runs 2. Rise 1, runs 2. And even if I graphed it a little bit wrong, I would be okay because I would know that it's got to be in quadrant 4. There's only one answer in quadrant 4, the positive negative answer of C. So now A is off. You could also solve this algebraically, but graphing is the easiest method here. But when we get to the next problem, 4, solve this system algebraically. So we have an equation 1. Y equals negative 2x plus 3. We have equation 1. This is y is isolated. So once you have one variable isolated here, y, we have the value of y, then we're going to definitely try to use substitution. It'd be too hard to use elimination. So we're going to substitute the value of y into equation 2, like so. So I end up with 2. And in place of y, I'm going to write negative 2x plus 3. And everything stays the same. Minus 2x equals negative 16. So I'm going to distribute the 2 to both terms inside of the parentheses. I got 2 times negative 2x is negative 4x. 2 times positive 3 is 6. I have variable terms both on the left, so I'm going to combine like terms. I get negative 4x minus 2x to be negative 6x. Now I'm going to go inverse operations. Remember, all three of these things I'm doing here, all three of these were from our Unit 2. So that's why it was really important to learn it in Unit 2. Inverse operations then tells me to subtract 6, because I work on the constant next. Negative 6x equals, I have a typo here by myself. This is 18, sorry, 18. So negative 18 minus 6 is negative 24. I'm going to divide by negative 6. And I end up with 1x equals negative 24 divided by negative 6 is positive 4. And I need to find y. Okay, well this equation 1 was isolated for y. So I'm going to use equation 1. And I have y equals negative 2. And in place of x, I know the value is 4. So I get y equals negative 8 plus 3, y equals negative 5. And I'm asked to write my solution as an ordered pair. So I need to write it as the x comma y. It's x comma y. I'll just put that right here. 4, negative 5 for problem number 4. Problem 5. What is the solution of the system of equations shown? Now, this is an interesting situation here, because if you look at both of these equations, I have equation 1. I have it in standard form, 2y minus 6x equals 42. And equation 2 is also in standard form, 2y plus x equals negative 14. So I'm going to solve by substitution. You do that when you see two equations in standard form. ax plus by equals c. Now they're lined up, but I can't add these together. I could subtract them, but we've been practicing using addition. So I need to change all the signs here so I can add them and they'll become 0. So I'm going to multiply and not change anything above. So times 1. But the bottom equation, I'm going to flip the signs by multiplying everything by negative 1. So nothing changes here. But here we get negative 2y minus x equals positive 14. Now I can add them together. 2y minus 2y is 0. Negative 6x plus negative x is negative 7x. 42 plus 14 is 56. I'm going to divide by negative 7. 56 divided by negative 7 is negative 8. I'm almost done. I need to solve one of them for y. It doesn't matter which one you choose. I'll choose equation 2. Two y plus, now instead of x, I know it's negative 8 equals negative 14. 2y minus 8 equals negative 14. I'm getting closer. I'm going to add 8. And I have 2y equals negative 6. Do some mental math, or dividing by 2, you get y equals negative 3. So make sure you write it in the correct order. X comma y. X is the negative 8. Y is the negative 3. So I look here. I could check my answers by plugging them in and verifying, but I have an answer here for C, negative 8, negative 3. Problem 6. How many solutions does the system of equations have? We have no solution, one solution, two solutions, and an infinite number of solutions. Let's take a look. We need to get them so that they're in the same. You could either make them both standard form or both slope-intercept form. Let's make them both slope-intercept form. Let's call equation 1 the 4x minus 2y equals 12. And we'll compare it to equation 2. Y equals 2x minus 6. I need to solve for y on the first one. Okay, I can do that. I have a variable term to get rid of here on the left, so I'm going to subtract the entire 4x. Nothing happens to negative 2y, the equal sign. However, these are not like terms. This is a variable term, and this is a constant. So I'm going to write my variable term first. They don't combine. You don't get 8x here. You get negative 4x plus 12, and that's fine. I then need to divide by negative 2. Remember, when we have an integer for a coefficient, we just divide by negative 2, but divide the entire right side by negative 2. So you end up with positive y. Negative 4 divided by negative 2 is positive 2x. They share this common denominator, so 12 divided by negative 2 is negative 6. So we end up with y equals 2x minus 6 for equation 1. Now we can compare that to equation 2. They are exactly the same equation. So that would just be one line, but infinite, solutions. D. Problem 7. For their summer jobs, Amanda and Julie are babysitting. Amanda starts with $350 in her savings account, and she earns $30 per week. Julie starts with $100 in her savings account, and she earns $40 per week. We can use these equations here to determine the number of weeks they will have the same amount of money. So let's take a look. We have Julie is a y equals equation. They're both isolated for y. So a variable is isolated. That means it's probably easiest to do substitution. Since they're both isolated for y, you can do graphing. It's going to be an interesting scale because you have some large numbers to deal with. So substitution ideally is easier Label your equations equation 1 and 2 before you begin. Y equals 30x plus 350. Y equals 40x plus 100. So we have something isolated for y in equation 1, so we can replace the y in equation 2 with 30x plus 350. What do you end up with? 30x plus 350 equals 40x plus 100. We just substituted for this y right here. That's how you end up with this. And then the rest is the same. Okay, well, variable terms on both sides. I just have to choose one side. Let's eliminate the 30x here. I know I said eliminate, but this method is substitution, so don't get confused. We got rid of the variable term here by subtracting it, additive inverses. 350 equals 10x plus 100. We're still trying to solve for x. We have a two-step problem left. Minus 100. And I have 250 equals 10x. So mental math, x would have to equal 25. So they ask you, use the following equation to determine the number of weeks they will have to save the amount of money. So x represents the number of weeks. We got x equals 25. That means it's going to be 25 weeks. Okay. So if I wanted to, I could go further. If there was a question, how much money does she make after 25? At 25 weeks, how much money did they both make? I could say, okay, so after 25 weeks, I have, after 25 weeks, I have to have y equals 40 times 25 plus 100. And this is in money. 40 times 25 is 1,000. After 25 weeks, you'd have $1,100. And I could write that as an ordered pair, 25 comma 1100. So 25 weeks, she makes $1,100. That's an ordered pair. And that leads to essential question number 8. What does the solution to the system of linear equations represent? Well, the solution is it's an input like x and an output such as y, or an ordered pair x comma y. That satisfies or answers both equations, linear equations. Or it's a point on a graph, which is also in XY, where the lines of the linear equations intersect. And finally, the last question. What are the methods for solving a system of linear equations? And we have 3 of them, and we'll keep it pretty simple. 1, 2, 3. To get the 2-point answer, you have to have the second part. The first half is just to name each one. We know we have substitution. And you don't have to list them in this order. We have graphing. And we have elimination. So under substitution, we isolate a variable. And substitute into the other equation. For graphing, we use slope-intercept form. And find the coordinates of the intersection. Sorry, I wrote so small. Intersection. Finally, for elimination, we have you eliminate a variable term by manipulating the equations, creating additive inverses. Okay, your Unit 4 CSA will be coming up, so make sure that you've studied this study guide so that you're prepared for the test.